Hey guys, so welcome back to the next class in this course. And so here we'll be picking up from our floor massing blocks, and then we're going to be using those blocks and transforming them into basically a wireframe model for our facade. In this case, we'll also create floor plates because at the end I want to have a kind of shell of a building. And so we're going to go through how we can deconstruct these boxes and start to extract the information we need for our facade and floors. So the first thing I'm going to want to do is just to reorganize the boxes so I know that they're in a particular kind of order. The reason why I'm doing this is because later on I want to be sure that the boxes are they're ordered in the correct way from the ground floor to the top. And so just to ensure this, and in case, as you're making your manual edits, you might change some of this stuff, I'm just going to use the area component, and then I'm going to deconstruct the center point that it gives us. And then I'm going to sort all my little boxes by their height. So now my box should be numbered in the list that comes out of it, 1, 2, 3, 4, 5, 6, 7, 9, 10. Maybe let me backtrack and just turn all this stuff off so we can kind of see what we're dealing with. So here we go, we got our boxes. So I'm going to continue to use the elephant description component. Like I said, again, just to kind of help annotate what I'm doing and to help you guys kind of follow along a little bit clearly. So these are my massing boxes. And so now that they're in the correct order, I'm going to graph them. And that's really going to be my the beginning of my data tree, right? So my data tree is essentially driven by each level of my building. We're going to use that as we move on forwards. Okay, we have our boxes. So the next thing I want to do is I'm going to deconstruct BREP and deconstruct this box into its faces. And then we're going to use the faces to create some of our elements. So again, I'm going to use the same little snippet just to ensure as my boxes are exploded, I want to sort them by where they are located in the Z direction. That way I know that the first item, the first face in my list is the bottom, and the last item in this list is the top face, right? That way I can immediately start to deconstruct what is essentially floors and what is facade. So now I'm left with my facade faces. Okay, so like I said, first thing, just a little tip there with the description component from Elephant, you can kind of continually create them or spawn them in a way. The way you can do this is to right click and then press L. So right click L, and it will kind of spawn these little description components. Really useful to just keep this going. And they kind of work in like a chain. So if I was to change this one, then the other ones will update. It does not go the other way. So if I go like this, it does not update. So it's kind of like you have to update the one at the beginning of your little stream. So we're going to just take a second to create the floor plates because we want to have them, and it should be relatively straightforward. In our list, in our data tree, we should have 6 faces for each one of our boxes. So in terms of creating floor plates, I'm just interested in the first item in my list and the last item in my list. And let me switch back to the select only. So here we have the bottom face, and this guy will be the top face. Okay. So we're going to use these to create our floor plates, but of course, the one little tricky thing about this is, of course, our floor plates are not, super simple in that now you can see they're overlapping. In some cases, we have what would be a balcony at the front, and then we have a kind of overhang at the back. So we need to do a little bit of work to join these together. It's not going to be too tricky, but we need to union these so that we can create our floor plate outline. So the way we're going to do this is we're just going to grab the Merge tool. We'll use the path mapper, and we will just renumber, and we're just going to go a -1, I think we need. And then we're going to join this back up. And simplify this guy. There we go. Okay. So now we have our 2 floor plates in each branch, and just to check and illustrate what we're doing here is if we look at one of our branches, let's say branch number 2, we should see our 2 floor plates overlapping each other. So if some of you are familiar with the Path Mapper, it basically allows you to kind of, in the same way, graft up or renumber your data tree based on the inputs that you put here. So in this case, we're just saying, I want the bottom face of the block below. And so that's how we get the bottom face and the top face together in the same data tree. Then when we go to, I think we want region union. If we look at what comes out of there, so we all have single, let's bake this guy. We have a single outline for each one of our floor plates, which is great. That's what we want. And we do want to fix one thing. What you'll notice here is when we did this, it's kind of shifted our data tree down. So now we have this kind of odd number in our data tree, this -1. I don't really want that. I want to kind of remap this so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because this will eventually dictate how we name our levels, right? I don't want to start with my ground floor is not level -1. That means my first floor will be level 0. So we're going to use the Path Mapper again. And it's always best to simplify before you go into one of these guys. And then we're going to do renumber, and we'll do a +1. So when we come out of this, we now have a clean data tree for each one of our levels, which is numbered 0 to 20. Okay, so you see the -1 has now become 0 and 19 becomes 20. So that's really it for our floor plates. Let's just end this in data description and we'll call this floor outline. Okay, and we'll kind of move this ahead. Of course, we could go ahead and extrude these and turn them into floor plates, which we might do later on. But right now, that's kind of all I need at the moment. I'm just going to be just interested in the outline for now. So that's our facade. So now the next part, which is the critical part, is the facade, right? And so we're going to take the faces that we have, and we're first of all going to cull away. We are going to cull by index, and we want to get rid of first and the last item in our list. And that way we are just dealing with the vertical faces of our boxes, which is essentially our facade. And so what we're going to do here is we're not going to create any kind of really crazy patterns or kind of facade panelizations. I'm just going to set up the idea of how we kind of can set up some options, some kind of leading design options, and how we can kind of script that into our overall scripts and have the ability to kind of change between one or the other. To start off with, I'm going to create a very simple facade panelization. So I'm literally just going to take the facade and I will divide it. Let's do divide domain and get the ISO trim. So this is our surface. And basically, I'm just going to create a facade panelization, which is very simple. I'm just going to subdivide every face by the same number, right? Because the building is kind of stepping, this will accentuate that kind of movement. So let's say we divide every face by 4 panels. You're going to kind of see, obviously, at the top, they'll be a little more regular size, or they'll kind of look similar. And then at the bottom, they'll fan out a little bit to accentuate the movement of the building. This is obviously a very simple idea, but I just want to kind of set you guys up with the idea of how you can set up more complicated facades and kind of bake in options that you can kind of explore as we move over to the Revit world eventually. So let's just have a look here. And of course, I need to graft my surfaces first. Okay, So let's have a look at what we're left with. So very simple, and I think this was an option in this project at some point. And you can see why, like I said, it accentuates the movement at the top. You can see the joints start to line up. In terms of the script, it's very simple, but it's got quite a nice look to it. So we're going to work with that as kind of one of our options. So we will call this fixed facade. Why is it fixed? Is because it's simply a fixed number. Every face is divided by a fixed number, which in this case is 4. So that's super simple. And then we're going to create a slightly more complicated one that's maybe a bit more rationalized. Basically, for the other one, I'm going to create a kind of fixed grid for the facade, which is another kind of pretty typical way for starting off how you do your panelization. So we're just going to grab all the bottom faces, and we are going to flatten these guys, because I'm not going to be using them for any kind of data tree wise. So, okay, we're going to flatten them, and then I'm going to project them onto a plane, and so this is all the geometry, and the plane is just going to be the world XY. The reason why I'm going to do this is I'm going to basically use this as a way to create a kind of grid. So we're going to use that, and then I'm going to create a bounding box. And instead of per object, I'm going to do a union box. So that's essentially going to be what creates our outline, right, for our grid. So we're going to grab this. Let's see if we can deconstruct BREP. So we can grab our edges. In this case, we can grab, depending how it's ordered. So this is our long face. And in fact, we can just go grab the length of our edges. And then we'll graft these. Let's divide that by a fixed number. Let's say our optimized panel, or like our nominal width for our panel, is 15 feet. And then we're just going to divide our curve. So these are our curves by however much this is. So these will essentially be our grid lines. And then we're going to create a perpendicular frame from these guys. And we're going to use the parameter. Okay, so now we have what we're going to use to basically intersect massing with. Let's just create a little this here. So this is our kind of grid plane. I do want to get rid of the first and last instances in our list, because they will intersect with the faces that are perpendicular to them. So I don't need the corner ones, I just want these guys. So we're going to use these to intersect with our facade faces here. And so let's give ourselves a bit of space down here. And let's do the same thing here. Okay, so we have our facade faces. These are our grid planes. And let's just bring these together. So you also see the way that I try to avoid, like every time you're coming out of a component, you have a description thing, and every time something comes in, you have a description component. And where I kind of move vertically, I try and do it in what's kind of known as a chimney. That way you start to create a bit more readable scripts rather than all these kind of like spaghetti scripts that you often see. It really helps when other team members come into this script. I'm away sick tomorrow and someone needs to work on the script. It helps to kind of guide them as to what's going on. But anyway, we are going to use, let's grab a BREP plane. So let's just check what's going on with our data tree. We have 80 branches and 4. And so I'm going to flatten this because we're going to use them all to intersect. So these are our planes. Okay. So if we look at this, let's turn the preview of our other facade off. And maybe some of the other things. Okay. So you can see now we have like a more regulated grid, right? This is probably much more rationalized in terms of construction. And this was sort of where we got to towards the end of this project. This was kind of where we started to get close to. So we're now left with what are essentially our kind of panel curves from here, or facade. Now, first of all, I want to shift these back because natively this component will graft every single one of them. So you see, I'm coming out of this with 2200 branches, and I was going into it with something like 80. So this is what the shift components does. I use the shift component, but I think trim tree also does the same thing. It's kind of slightly different. I'm a bit of a shift pather rather than a trim tree, but anyway, each to your own. And so there's a few things we're just going to add here is that you'll see that some of the intersections, like this guy, creates a super tiny panel, right? So that is going to later on cause issues. We're never going to be able to create any kind of Revit panel in this little gap that's not what's, a simple rectangle. And simply this is not buildable. So we need to create a little snippet to get rid of some of these strange panels. This guy, maybe this guy if it's too small. So one of the ways we're going to do that is we're going to grab our faces. We still want them. And we are going to grab the edges. And so let's keep this simple. I think this should do the job. So we basically have the outline of our facade. Let's grab this. This is our facade outline. And what we're going to do is we're going to measure the distance between the center point of our panel curve and the edge of the panel. And then if it's smaller than a certain distance, we're going to get rid of them. So the way this is going to work is we're going to grab this curve. I want to grab point on curve. There we go. So we're going to grab basically what is the center point of our curve. And then we're going to use curve closest point. So this is the point we're searching from, and this is the outline that we want to measure. We want to find the closest point to. So in most cases, the closest point should be the top of the curve, but in some cases like this one, you'll see here. And as a byproduct of this component, it gives us the point on the outline of our facade outline, but it also gives us the distance that that point has traveled, which is pretty handy. And so we're going to use that to kind of filter out or dispatch the ones that are smaller than a certain distance. So we're going to use the dispatch component, super useful component, which we use all the time. So this is our list. And we're going to say if the distance is smaller than, let's say the minimum size that we can make a panel is 5 foot, right? I'm just going to run with that number, panel width. All right, and this will basically give us a list of true and false values. So most of them should be false, so we've got a couple of true ones here. And I'm going to plug that into my dispatch pattern. And then on the other side of this, we should have, if we do this guy, these are the ones that are within that we kind of want to get rid of. Let's see if I can see that. So you can see this guy here. So this guy is too small, great. So we just want to keep all the ones that are not within that range. So there we go. Or what we should have done is larger than, if this distance is larger than 5. And then that way it's kind of simple. All the true ones are the ones that we want to keep. So let me just select one of the surfaces. So there you go. You can see now that this guy has the mullion missing out of it, which is fine. You can also come back here and you can play with what that distance is. I think 4 feet. 4 feet would probably maybe be realistic. I'm just going to stick with 5 feet just so it doesn't, create any issues later on when we're making the Revit panel. So that's it. So we basically have two, they're not really super complicated panelizations, but we have, or like panelization options, but we have 2 options really for our facade in terms of panelization. We have a fixed facade where we have this done by a fixed number. And then the other one, we'll call it a grid facade. And we basically have our 2 options here. So we have a grid facade Oh, sorry, missed one step before we get to this point. Let's just move this on. Of course, we need to use our curves to split our facade. So that's the key thing, because we want to end up with a surface. So this is our facade. So I'm going to bring that across here. And always just double check our data tree is good. 80 and 80. Boom. Okay. And now we should have our gridded facade. There we go. We can bake these and just have a look, see if it's all good. Perfect. So, yeah, like I'll say again, now we have our two facade options. We have our fixed facade and our grid facade. Okay, and so basically what this little chunk is, what I'm trying to show here is that this is where you'll create your leading options for your panelization script. So, you can obviously add 3, 4, whatever stages you're coming out of. Let's say there's 2 or 3 kind of ideas that are still in the mix. We can keep these here, and then we're basically going to use them. We can choose which one that we want to use in order to output the information that we need to move across to our Revit world through the script there. I'm also going to bring a floor outline. So here I'm just creating a break in the script. So basically at this point, see here, this little chunk that we just created, and essentially it's this part here. We're creating our facade and our floor plates. And so I think this is where we're going to leave off for this class. We've essentially created what's known as a wireframe of what we're trying to create. We have an outline for the floor, and right now we have surfaces for our facade that have been divided into what represents our kind of facade panels. And so in the next class, we're going to look at how we can take these surfaces and then create an output for the next stage in our process. We'll see you in the next class where we'll pick off from here and move on with our surfaces.